Math is a wonderful thing. Math is a really cool thing. So get off your ass, let's do some math. Math, 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 math.
Okay, so we've got a word problem, okay, for us. This has a lot of questions in it. This one word problem will be able to help you with this whole exercise. Okay, so because we're all bored, as all get out, stuck at our house and we like to cause trouble. So someone in your neighborhood is shooting off fireworks off their back deck for entertainment. The height in meters, X seconds after one of the bottle rockets is launched, is modeled by this function. H of x is equal to -4 times x plus 5 times x minus 22. Now, I will not ask you to come up with that, all right? It's going to be given to you. But we're going to have to be able to answer some of these questions. Okay, so x is time, okay? X is seconds. H of x, okay, is height after a certain amount of time. Okay, so what is the height of the bottle rocket at the time of launch? Well, I'm searching for the height, and I just need to know, well, what is the time of launch? What does that mean? Okay, well, if it says that this is modeled by X seconds after its launch, so it's like we took a stopwatch, and as soon as that thing lit up, I hit the button, or I hit go on my timer. Okay, so at the time of launch, well, that is when X is equal to 0. Okay, so I want to know, what is H of x when x is equal to 0? So what I really want to know is H of 0. Okay, so that means wherever I see x in my equation, my function, I'm going to plug in 0 and solve for it. Okay, so 0 plus 5 is just 5, and 0 minus 22 is -22. So I have -4 times 5 times -22. Well, -4 times 5 is -20. So -20 times a -22 is a positive 440. This is a massive bottle rocket. So my answer is 440 meters. Okay, that's I guess it's not a massive, but they're just really high up in the air. That's what that means. So this is the starting point of the rocket, like the platform that they are shooting it off of, which I made these numbers up. So it's really high, like on top of a skyscraper or something. Okay, so the next question here, we have how many seconds after launch will the rocket hit the ground? Okay, so I'm looking for how many seconds. So that means I'm going to be solving for x. Okay, seconds after launch, will the bottle hit the ground? Will the rocket hit the ground? So what is the height of the rocket when it's on the ground? It's 0. Okay, so I'm gonna set my whole thing equal to 0, right? So it's 0 is equal to -4 times x plus 5 times x minus 22. This -4 doesn't really mean anything to us. I'm just kind of worried about this and this right here. So we're going to use the 0 product property to solve for x. So if x plus 5 is equal to 0, that means x has to equal -5. Okay. And then the other one, x minus 22 is equal to 0. X has to equal a positive 22, right? Because I have to add 22 to both sides. Now, let's think about this logically. The question asks for how many seconds? So I got my two answers, -5 and 22. So you tell me what planet we can have negative time on, and then, our answer will be -5. All right, so -5, while it is a solution to this problem, in a real life scenario, it doesn't make sense. Okay, so this isn't an option. Okay, so I only have once after 22 seconds. That's how long it takes for the rocket to hit the ground. Okay, so 22 seconds. Okay, how many seconds after being launched will the bottle reach its maximum height? Okay, this is a good question. Max height. If we were going to graph this, I'm just going to sketch a graph. We kind of already know what parabolas look like, right? And you kind of know what this is going to look like. It's going to go up and then come down, because when you throw something, when you shoot something in the air, it comes up and then it has to come down, right? So I'm just sketching a graph. It's not going to be accurate by any means. That doesn't really matter. But it's probably going to look something like this, right? Okay, well, from this I have some pretty unique characteristics that we know. Okay, height is right here, and time is right here. That's x. I'll call that x, since we're using x in this problem. Okay, well, the two places, according to, if height is 0, it's right on that x-axis, correct? So right here, that's x is 22. And right here, x is 5. All right, what's really cool about this is my vertex. Oh no, my vertex, okay, will be right in between that. So I just need to figure out what's the middle point between 22 and -5. I don't know why I wrote 5. -5 over here, okay? I just need to find the average. So to find the average, I take -5 and I add it to 22, right? And then I divide by 2. The 22 minus 5 is, oh, I picked really bad numbers. I did not think about that. Sorry guys, we're gonna have to deal with fractions. You'll be all right. That is 17 divided by 2. Okay, let's go ahead and get our calculator out and do some decimal work. That is 8.5. It is okay to use decimals. It's okay to use your calculator. All right, I am pretty sure most of yours won't be as ridiculous as what I just did to you guys. I'm sorry, but that's okay. We can still solve it. So after 8.5 seconds, okay, it's like you're watching and 8.5 seconds go by, it's gonna start coming down. All right, so this is 8.5 right here. So now my last question here says, what is the maximum height that the bottle rocket will reach? Okay, well, I know how long it takes for it to get to its maximum height, right? 8.5 seconds. So I just want to know, what is h after 8.5 seconds? 8.5. So what we are going to do is plug in 8.5 into our equation for x. Okay, you don't have to worry about, the h of 8.5, okay? I'm just worried about this right-hand side. So let's do 8.5 plus 5. This -4 is going to stay right here. And I get 13.5. I'm just using my calculator right now, guys. It is okay. 8.5 minus 22 is -13.5. All right, now it's just a bunch of multiplication. This is going to be a pretty big number, okay? Because it's already starting at 440 meters off the ground, so it can only go up from there, right? Because its starting point, the very first question, what's the height of the bottle at the time of launch? That's this guy right here. That's 440 meters. I want to figure out, how high does this thing go? So I'm going to multiply -4 times 13.5 times -13.5, and I get 729 meters. It is positive. That's my max height. All right, so this should help you with some of the questions on here. If you need more help with this, let me know. Thank you and enjoy.